Dear students, in our last video class, we have learnt about some very important concepts related to projectile motion. We learned the definition as well as the other terminologies associated with the projectile motion, and also we derived an expression for the projectile motion, and through that expression we came to know about how will be the equation of trajectory of a projectile. In today's class we are going to find the expressions for time of flight. Definitely we will come to know about what is the meaning of time of flight, and later we are going to derive the expression for time of flight. After that we derive the expression for range of the projectile. Right, definitely here also you will come to know about what is the range, then how to derive the expression for range of the projectile. Then finally we discuss about the maximum height reached by the projectile, and we also derive the expression for that. Okay, so let us start with the second derivation related to the projectile motion, that is finding or deriving the expression for time of flight. Okay, dear students, for all these derivations we have to consider the same diagram what we have learnt in the previous video. Yes, for the oblique projection of a projectile, what are the terminologies and the things that we discussed. The same concepts or same terminologies and concepts are being used in the derivation of the remaining equations. So let us start off with this. Now, what do you mean by the time of flight? Dear students, whenever an object is thrown obliquely, right? For example, from point O, if one object is thrown obliquely by making an angle of theta with the horizontal line, then that object moves in the air. As soon as we release the hand, as soon as it escapes from our hand, it moves in the air, it takes the trajectory and it moves along the trajectory, and finally it comes back to the ground. So from the instant of releasing that object, yes, from that instant to reaching the earth, how much time it takes, right? That time is known as the time of flight. Okay, or in another words, it is the total time taken by the projectile to remain in the air. Okay, soon after the projection, whatever the total time for which the projectile remains in the air, so that time is known as the time of flight. So it can be defined in two different ways. Okay, the first way is what? The total time by the projectile to reach the ground. Okay, so this is one definition. Or you can define the time of flight in a different way. That is, the total time taken by the projectile to remain in the air. Yes, so this is another way of defining what is the time of flight. Okay, dear students. So therefore here, if O is its starting point, O is the starting point of the projectile, and after some time if it reaches the point M on the ground, then whatever the total time it will take to reach the point M, it is the time of flight. Now how to derive the expression for this time of flight? That is very important. How to derive the expression for the time of flight? For that, what we do, we divide that whole concept into two parts. In the first part, we find the time taken by the object to reach the maximum height, that is the point H. If I represent point H in the trajectory as the maximum height reached by the projectile, then how much time it takes to reach from O to H. So that we have to calculate. Once we get this time, then the time to reach the ground from this point H also will be the same. Okay, remember this. So I repeat it once again. Time to travel OH path will be equal to the time to travel the path HM. Hence, if we know how much time it takes to reach the point H, then just you double it, then that will give you the time of flight. Okay, that is the simple trick what we are using. Then, how to know the time taken by the projectile to reach the maximum height? Yes, for that we are making use of one equation what we know from the equations of motion. We know that V is equal to U plus AT. Here you know that V is the final velocity, right? And U is the initial velocity, A is the acceleration, and T is the time taken. Okay, so dear students, here when the object reaches the height, the maximum height, then its velocity at this point becomes zero. Almost it will be having the zero velocity. When it reaches the maximum height, its velocity becomes zero. So here the final velocity at point H is taken as zero. Then what about the initial velocity? Yes, see, initial velocity is actually it is U, but as the object is reaching the height, that is, as the object is covering the vertical distance, so we have to consider the vertical component of the initial velocity. What is vertical component of the initial velocity? Yes, it is Uy. So Uy is the vertical component of the initial velocity. And we know that Uy is nothing but it is U sin theta. Okay? Now, let us move towards the concept of acceleration. Yes, what is acceleration? See, here one acceleration is definitely acting on that projectile, and that acceleration is called as acceleration due to gravity. As the object or the projectile is moving upwards, the acceleration due to gravity is represented by minus g. Hence, acceleration is nothing but acceleration due to gravity, and it is minus t. And we need not worry about this time. So, time taken, it is considered as small t only. Now, if all these changes are made in the equation of motion, what we have taken, that is V is equal to U plus AT, then what changes will occur? Yes, see here dear students, initial velocity is 0, then U is nothing but Uy minus A is G into T. Okay, or the same thing is written as, see, Uy is nothing but it is U sin theta, therefore it is U sin theta minus G into T. I want to know what is the time taken. Hence, this entire term gt is taken to the left hand side. So G into T is equal to U sin theta. Therefore, T is equal to U sin theta divided by G. So, dear students, this is the time taken to reach the maximum height. right? That is point H. So this time taken is also known as time of ascent. It is also called as time of ascent. Try to understand it. Time of ascent. Now, this is the half part. This is one part of the whole derivation. What actually we need? We need the total time of flight. So I told you earlier, the time taken by the projectile to reach the point H from O will be equal to that of the time taken to reach the point M from H, isn't it? Therefore, see, from point H onwards, the object or the projectile starts to come down. So that is called as the descent. It is called as descent. Ascent, its opposite is descent. Hence, the time of descent is equal to the time of ascent. Okay? Hence, the time of descent is also same as that of the time of ascent. Therefore, the total time taken, okay, so which is nothing but time of flight. Yes, it is also the time of flight. It can be written as, see, the total time taken can be written as 2 times of time of ascent. I can write it like this because both ascent and descent are equal. Hence, instead of taking ascent plus descent, I can take 2 times of ascent. Hence, it is T is equal to 2u sine theta divided by G. Dear students, this is the final equation for the time of flight. It is the final equation for the time of flight. Hope you got the way of deriving the equation. It is very simple. See, quickly I want to make the revision. First, you have to understand what actually is the time of flight, right? After that, you need to consider the equation of motion, what we already know, that is v is equal to u plus at. So in that, you have to identify the value of each term. What is the value of v, u, a and t? Then substitute those values, then modify the equation for t. When we modify the equation for t, and that itself is considered as the time of ascent. Okay, so time taken to reach the height up to point H. Then after that, the object starts to come down, that is called as the descent, and time of descent will be equal to time of ascent. Hence, the total time of flight is time of ascent plus time of descent. So instead of writing like that, see, we can write total time taken or time of flight is equal to 2 times of ascent. Hence, it is capital T is equal to 2u sine theta divided by G. Hope you got the derivation easy. Do practice, and definitely any one of these derivations which I am going to cover in this video, they are going to appear in your examination. Okay, dear students, now let us move towards the derivation of an expression for the range. So before starting off with the derivation, first let us understand what actually is the range or range of the projectile. See, it is very simple. Okay, it is the maximum distance or maximum horizontal distance traveled by a projectile is called as its range. Dear students, I repeat it once again. The maximum horizontal distance or the total horizontal distance traveled by the projectile is called as its range. So it is the total horizontal distance. Okay. So here, if one projectile is thrown from the point O, see, after the time t, that is capital T, okay, time of flight, it comes back to the earth, and suppose it reaches the point M on the earth or on the ground, then whatever is the distance between O and M, so that distance is known as the range of that projectile. Right. Now, on what factors this range depends? That is very important. Right. On what factors? Because depending upon some factors, that distance will change. That distance may be too short, or it may be medium, or it may be very large. So depending upon few external factors, that range of the projectile depends. So that is our aim. We have to know on what factors the projectile, the range of the projectile depends. Right. So to know the factors, we need to derive the equation of the range. So to derive the equation for the range of the projectile, first we have to consider an equation what we have already learnt. Okay. According to the equations of motion, we know that S is equal to ut plus half at square. Okay. So dear students, already you know all the terminologies or the symbols which are there in this particular equation. So S is the distance traveled. Okay. So T is the time. Time factor or time of motion. Right. Total time of motion. And U is the initial velocity. Okay, and A is the acceleration. Now we have to apply all these factors to this particular diagram what you are seeing. Observe the diagram, dear students. Here R is the range, or it is the maximum distance or the total distance travelled by the projectile. Therefore the distance travelled can be represented by R. Now of course the time of flight, yes, it remains the same, you keep it as it is, or you can consider it as capital T, because it is the time of flight, the total time taken by the projectile to reach the point M. So you can consider it as capital T, or the time of flight. And initial velocity, here you must be very careful. Why? Because see, the object is moving to be considered in the horizontal direction, or in what direction the displacement has occurred. See, the displacement has occurred along the horizontal line, isn't it? So therefore the velocity component of the initial velocity, it has to be taken which is along the horizontal axis. And we know that along the horizontal axis the initial velocity component is ux, and its value is, of course, it is u cos theta. And what about the acceleration here? Here, it is also very important to note, because in this particular case, the acceleration is 0. Why? Because you may be wondering why it is 0. So recall what you have learnt in the previous class, just to go through the previous video, dear students. For your better understanding purpose, what I am going to do, I am just recalling it. See, U is resolved into two components. One is Ux and another one is Uy. Okay, and I told you that the horizontal component of the velocity is uniform velocity. It is the uniform velocity, right? Whereas this vertical component of the velocity is non-uniform, or it is a varying velocity. It is a varying velocity. So therefore, as we have to focus on ux, that is the uniform velocity. If the velocity is uniform, then there is no acceleration. Hence, the acceleration is taken as 0. Okay, I hope you got the purpose of taking the acceleration is equal to 0. Right. Now you substitute all these factors, the terms related to S, T, U and A in the above equation, the equation of the distance travelled what we have taken. Right. So in this equation we have to substitute all the things. Then what we get? See, observe it. In the place of S I write R is equal to U. It is Ux. Instead of small t I write capital T plus half of acceleration is 0 and t square. Yes. So the whole second term becomes 0 and we are left with R is equal to Ux into t. Now, we know what is the value of Ux. Ux is nothing but it is U cos theta, and from our previous derivation we know the equation or the expression for the time of flight. It is 2U sin theta divided by G, isn't it? Hence, just to multiply the two terms here, it is 2U square sin theta into cos theta whole divided by G. Okay. Now I want to make a small change. What I do, I write it as U square 2 times of sin theta into cos theta together. Okay. Then denominator is as it is. Here, just to make the observation, dear students, the terms which are present in the bracket, they are nothing but they indicate one identity related to trigonometry, and we know that 2 sin theta into cos theta is sin 2 theta. Okay, so instead of that, those terms which are in the bracket, I write U square sin 2 theta divided by whole divided by G, and this is the final equation for the range of the projectile. Okay, it is the final equation for the range of the projectile. A very important equation. Now, when you look at this equation, you will come to know about on what factors the range depends. Okay, how much distance will be covered by that projectile, it depends upon all these factors. See, it depends upon the initial velocity. If the initial velocity is more, if you throw with very high velocity, then it covers the larger distance, right? So it also depends upon the angle of projection. Okay, it also depends upon the angle of projection. If the angle of projection is more, it covers the longer distance. If the angle of projection is less, then it covers the smaller distance. And it is inversely proportional to G, that is acceleration due to gravity. Of course, it is a constant, so it is not going to affect much on a particular region of the earth. Okay. So the two main things are, one is U, the initial velocity with which you throw the projectile, and the second one is the theta, that is the angle of projection. Okay. So dear students, after the derivation of this equation, we are moving towards the derivation of the third concept. Now, dear students, let us derive the expression for the maximum height reached by a projectile. Okay, so what is the maximum height reached by the projectile? In this figure, observe it. PQ represents the maximum height reached by the projectile. Okay, and usually that maximum height is denoted by this symbol H. Okay, hence, to get the equation for this H, yes, we need to make use of one more equation of motion. Already we have used two equations of motion in our previous two discussions. So here we are going to make use of one more equation. We know that from the equations of motion, V square is equal to U square plus 2AS. Okay, so this is the equation what we know from the equations of motion. Now, dear students, when you observe this figure, see, as we have to focus only on the height, So I have to consider the maximum height, that is point Q, reached by the projectile. So at point Q, how will be the velocity, or what type of velocity is there, or what will be the final velocity, what will be the g value, that is acceleration due to gravity. So all those things have to be taken. Hence, at point Q, if you consider, see, I am writing it clearly, at point Q, that is the maximum height of the projectile, yes, final velocity becomes 0, right? At that instant, that fraction of time, so final velocity, its velocity becomes 0. After that, again its velocity goes on, increases. As it comes down, its velocity goes on, increases. So at this point, its final velocity will be 0, right? Then what about the initial velocity u? See, as we are considering the displacement of the object in the vertical direction, hence we have to consider uy, that is the component of the vertical component of the initial velocity, that is uy, right? And we know that uy is nothing but u sine theta, right? Then what about a? It is minus g, that is acceleration due to gravity. It is represented as minus g. Then what is this s? S is nothing but the distance traveled. So assume that, see, as we have to measure the distance, that is the height, then always we have to measure it from the ground only. If we want to measure the height, then we have to consider the initial point as ground only. So from point P, how much distance it has traveled, it has covered. So that is called as the what distance traveled, and that distance is nothing but the height or maximum height reached by the projectile. Hence S is equal to h here. If all these changes are made in the equation what we have considered earlier, then what we get? See, v value is 0, u value is uy, so uy whole square plus 2 times of a is minus g and s is h. Okay, see, I have made all these substitution here. Then see, uy is nothing but it is u sine theta, therefore it is u sine theta whole square minus 2gh. Now shift this 2gh to the left hand side. It will become 2g into h on the LHS. And what about the RHS? It is u square sine square theta. Okay, so this is RHS. Now as I want the value of h, so what can I do? Just shift to 2g to the right hand side. Then h will be equal to u square sine square theta divided by 2g. Okay, so dear students, this is the final equation, or it is the equation what we have derived for the maximum height reached by the projectile from the ground, right? It is the equation related to the maximum height. Sometimes it is also represented as h maximum. H maximum is equal to u square sine square theta divided by. When you observe this equation, we come to know that the maximum height reached by the projectile again depends upon two factors. One is u, that is the initial velocity with which we are throwing it. Then second one is the theta, in what angle, in what direction we are throwing it. Okay, so both these factors, they play a very important role in deciding the maximum height. Okay, dear students. Now here, if you consider one particular case, that is, what if the angle theta is equal to 90 degree? A special case, just for the purpose of discussion. If theta is equal to 90 degree, what happens? Yes, we know that sine of 90 degree is 1. Hence, the maximum height reached, that depends upon only the initial velocity. So we get the equation u square divided by 2g. Correct. Remember this. These are the 3 derivations what I have covered in this particular video. And most of the time, any 1 or 2 derivations will be asked in the examination. They may make the combination out of 4 derivations what we have learned. Okay, out of 4 derivations, see, they can make the combination of any 2 derivations, and they may ask you the thing for 3 marks, or it may be for 4 marks, or sometime even it may be for 5 marks. But anyway, the derivations are not so difficult, but if you prepare well and if you understand them properly, right, you will definitely solve them perfectly. Okay, so I will continue my class with the next video. See you.